Okay, so some basic terminology first for complete beginners to programming. So you have your code, which is just a sequence of instructions to your computer. Syntax is basically like the grammar of any programming language, and you need to follow the specific grammar, or else your IDE or whatever is compiling your code will give you an error. The output is, for example, what we'll be doing is just print statements to your console, and your console is the output box where you will see your text. So unlike other programming languages like Java, Java uses a JDK to compile your code to another form of bytecode, which is more lower level code, and then that is what is executed into your computer to understand, and it'll give you your output. But instead, Python is just directly interpreted from whatever you have written directly into the output. So first, let's start off with some basics, which is so expressions. So I'm sure a lot of y'all have taken basic math courses. We have like basic multiplication, addition, division in Python. So we have, and then we also have modulus, which is you take, let's say, 5 modulus 2, it will return 1 because that's what the remainder is of 5 divided by 2. And then we also have exponents. And the important thing in Python is there is a specific order in which operations are calculated, similar to what you have in math, your PEMDAS. So multiplication, division, modulus, and exponents take a higher priority than addition and subtraction. So integer division is a little bit different between Python 2 and Python 3. It depends on what specific Python you are running. So in Python 3, integer division doesn't really exist. So when you do, let's say, 84 divided by 10 in Python 3, it will be 8.4. It will return the real with the decimal. In Python 2, it will just floor your division. So it will take off whatever the decimal is. So 84 divided by 10 would be 8. In Python 3, you can mimic this function by using 2 slashes. So that would just give you the floor division. So another data type in Python is real numbers. I'm sure you've seen real numbers, basically with decimals, and also negative numbers, very large numbers with 10 to the power of 17, etc. So you can see here 15.0 divided by 2.0 will give you a real number as well in division. In Python 3, this is going to be the same as 15 divided by 2, just as in integer form. So this is more prevalent to Python 2 calculations, where like 7 divided by 3 would floor your answer to 2 instead of it being 2.5. But this isn't really relevant in Python 3. So here are some basic math commands that you have in Python. We have absolute value. It just turns whatever you pass in here to a positive number. Ceiling rounds up, so like 5.4 will become 6, etc. You can see that these are all the different functions that the math library provides for you in Python. Important thing to note is that you will need to import this library at the top of your code by just simply adding this line, because we don't actually download or like import all the libraries, because we might not need to use them and it'll take up a lot of memory. So we import them as we seem fit. And there are of course default libraries where it's automatically imported because we use the most common. So here are some basic functions that we can do to convert between floats and integers. So integer x, as you can see here, converts 2.0, which is a float, which is also known as a decimal, basically, into an integer, which is 2. And then float x converts an integer into the decimal form, so 2.0. This is useful because, like, for example, you can convert. So, like, for example, a 2 can be a string, which is another data type. Let's say like a word in Java. So like a word in Python is like a string, and then you can convert that into an integer if that string within that string isn't actually a number. We'll see where this is useful later on. So variables is a crucial part of programming because this is how we store data within each of our programs. So let's say here you want to like take x is equal to 5, right? And then maybe we'll need to use this variable later on in some other calculations, like adding to it, multiplying some other value by it. So it just gives you a way to be able to store values and use it later on. And it gives you a sense of abstraction too. So you can just change this value at the top of your code and it will change all of those values where you use this variable later on in your code as well. The important thing to note is that the left side is the variable and then the right side is whatever you're assigning that variable to. You do not want to get this swapped or else it will cause issues in your code for sure, especially when you're assigning a variable to another variable as well. There will be exercises at the bottom that I've given. I'm not going to actually go through this because the presentation is quite long and I don't want to take up too much time so we can get through everything. So you can jot these down and work on them later if you feel like so. Here is a simple variable assignment. So let's say we put x is equal to 7. If we print x, x is 7, and then we want to, let's say, add 7 to x, it'll give you 14. And then we can also set x to, like, this is what I was talking about, a string. So hello, and then x can also be hello. So let's get onto our first real method really that we've seen. So print. So we can give the print method like a string and it will print it out to our console. So let's say we say print hello world. And then here we set the variable age to be 45. And then we can also print. So this comma right here is basically adding this string plus this string with a space in between. So it converts 65 minus 45, which is 20, into a string. And then I'll add it onto this string. That is what we call concatenation too. It's when you put two strings together. And then this is also another concatenation. And you'll see we have it printed out as you have 65 minus 45, which is 20 years until retirement. Okay, so this was what I was talking about, the concatenation. When you put a comma in between two strings, it'll add them together as one string with a space in between them. Pretty simple. Okay, so input is another function that we have in Python where you can take in a user input now. So let's say we have age is equal to input, and then our parameter is how old are you? So when we run this code, it'll print how old are you, and then the program will wait here until you enter a number, until you enter an input, which is, let's say 53 in this case, and then it'll set your variable age to be 53, right? And then you can print out whatever, or it'll run whatever code you have after that. And you can see here we have a print statement, your age is 53, whatever you inputted, and then also this other print statement that we have here. Okay, so now let's move on to loops and if else statements. So we have two different loops in Python. The first one is a for loop. So a for loop, basically, let's take this example first. So for x in range of 1 to 6. So we're setting a variable x to be going from the range of 1 to 6. So basically 1, 2, 3, 4, 5, and 6, right? So then we'll print x squared is x times x. So basically, the first time this loop runs, x is 1, right? It'll start at 1, and it'll print 1 squared is 1 times 1, which is 1. And then it'll increment x to be 2. And then it'll be 2 squared is 2 times 2, which is 4. And then so on until it reaches, this is, so the right bound is what we call exclusive. So it will never actually, it'll run until the number before 6, so 5. So 1, 2, 3, 4, 5. And then it will break once x hits 6. So you can see here only prints out x from 1 to 5, and then their square numbers. So that range function that we saw in the previous example, we can also give it a step incrementation, which means basically we can set it to be going downwards, for example, in this case, from 5 all the way down to 0. Or we could, let's say that this was 0 and this was 10. We can put 2 here and it'll increment by 2 instead. So it'll go 0, 2, 4, 6, 8, and then it'll stop before it reaches 10 because 10 is exclusive. All right, so if statements now. So I mean, if statements is pretty simple. We have like the keyword, we use the keyword if and then a condition. So let's say that like we say that if GPA is greater than 2.0, so if this condition is true, we set like a specific condition here. If that this is true, we run whatever is within the if condition. So the important thing to note is the notation here with the colon and also the indentation here, which is a tab basically, but this is important in Python because that's how you block your code in Python, and that's what it knows what to run. If this if condition is true, it's whatever is indented within this if condition. Simple flowchart of a if condition. If it is true, we run whatever is within the if condition. If it's not true, then we will go on to the else. Else basically means if this isn't true, then we run whatever is in this else statement. So simple flowchart here too. If the first statement isn't true, we go to whatever is in else, and then we run that. And then we also have else if, which is simplified to be elif in Python. And that is just, we're checking these statements sequentially. So if this first condition is true, we run whatever is within this if condition, and we don't check the rest of these statements. However, if the first if condition isn't true, we check this else if condition. And if that is true, then we run this else if condition. We can have multiple else if conditions and then an else at the end. And if all of the if and else if statements aren't true, we run the else at the very end. Simple flowchart here too. So you can see how we're checking the first if here. If it's not true, we check this else if statement. And if this isn't true, then we're going to be running this else statement here. Okay, so now let's move on to while loops, since we're a little bit more familiar with like conditions. So while loop basically is a loop that keeps on looping until this condition becomes false. Okay, so let's say we have this example here where a number starts to be 1, right? While number is less than 200, we print the number and then we multiply that number by 2. So basically what this code is doing is the first time it runs, 1 is less than 200, correct? So we're running print number, so print out 1. And then 1 times 2 becomes 2, right? So now while 2 is less than 200, right? So it'll do the loop again all the way up until 128, because once this number hits 128 and you multiply that by 2, that's 256, right? And 256 is no longer less than 200. So this while loop breaks and we'll never be able to print 256. This is another simple example of a while loop as well. Okay, so these are some of the logical expressions that we use for conditions. Like, so we can have comparating. So like comparators here, which is basically saying, let's say if 1 plus 1, we use 2 equal signs to compare if the values are equal. You want to use these for things like integers, floats, characters, but we'll get onto why equals is a little bit tricky when you're comparing objects. It's not exactly the same, but let's just focus on, let's use integers and floats, for example. So 2 equal signs compares if the value on the left side is equal to the value on the right side, and it'll return true if it is, and it'll return false if it isn't. So true and false is another data type in Python, which is called a Boolean. So a Boolean just takes the value true or false, pretty simple. And then does not equal to is an exclamation mark and an equals. So if these two are not equal to each other, we're returning true. If they are equal, we return false. And then we also have less than, greater than, less than or equal to, and greater than or equal to. These are some examples here. And then we also have, we can combine these operators too, these comparable operators. So let's say that we have 2 different conditions that we have to meet, right? So if 9 does not equal, so if a number does not equal to 6 and a number is less than 3, we can return true. So for example, in this one, since 9 is not equal to 6, so since this side of the and is true, and also this side of the and is also true, we will return true, right? But if one of these is false, then we will end up returning false. And if both of them are false, we return false as well. It gives out false. And for or, only one of these has to be true in order for this operator to become true as well. So these are some simple loop control keywords that we use in Python. So let's say you have a for loop that is looping, and then you hit an if condition within that for loop. So I can open up. Let's say we have for x in range 5, right? So what this is doing is x is 0 all the way to 4, right? So let's say that if x is equal to 3, then we break, and we can do print hello, right? So what this is doing is that if this condition is true, that we break out of the loop. So basically, we will only be printing hello 3 times, right? Because once x hits 3, we are breaking out of this for loop, and we will no longer be printing hello anymore, right? And then, so continue. Continue basically means we skip this iteration of the loop. So let's say that so x was 0, 1, and 2, right? So we've printed hello 3 times so far. And then now x is 3. So we do continue. So basically it skips past whatever is within this loop, and it goes on to the next iteration. So then x becomes 4, and then 5. So it will only print out hello 4 times, right? And then pass is just so it's just a placeholder for like doing nothing. Let's say an empty class. We'll get onto what classes are in a bit. So here is another example of a way we can use for loops. So we can put a list as an argument for a for loop. Let's say we have the list 1, 2, 1, 7, 13, 2, and we do for x in this list and print x. So x will take on the value of each index in this list, which is 1, 7, 13, 2. We'll go over what lists are and like why they are very useful in a bit. And then this is the example I had for x in range 5. Basically, it starts from 0 all the way to 4, since 5 is exclusive. So here are some other data types in Python, which is complex. We have complex numbers in math too. So I, which is like, this is a representation of I, which is square root -1 in math. But it's just how you can represent it in Python as well. So we can also use the plus sign for concatenation. So usually plus is between like two numbers, right? Where you can add like 5 and 4 and it'll be 9, right? But we can also use plus between two strings because we'll get onto this later on, but strings in Python are also class, right? And within that class, they overrided the plus function. So you can actually concatenate two strings using a plus sign instead. So you can represent strings using single quote or double quotes. And then you can also do 3 double quotes for a multi-line string. So something like you can type multiple lines, hitting enter, and it won't give you a syntax error. So we need a way to also we need a way to be able to alter strings too, right? In Python. So we can so strings are basically made up of so in Python, we have characters, which are like single letters, and then also strings, which are made up of like multiple different characters, right? So a string can basically be represented as a list of characters. So when you look at this example here, like S is the string 0, 1, 2, 3, 4, 5, right? And then we do this notation, which I'll talk about a little bit more later. So S, actually, I'll get to it right now. List. So let's do list first. So list is basically a data structure, a simple data structure in Python where you can use it to store information or like store certain variables that you'll need later on. It's basically it's like a library with books within that like certain shelf of within that library, right? So you can see here X is the list that has 1. It holds the value 1 at the first. So this is an index 0, and then hello is at index 1, and then 3 plus 2j is at index 2. So lists in Python are mutable, means you can add to the list, you can remove items from the list. So you can basically change the size of the list, right? So you can see here when we do X with the square brackets, this is the notation to access a certain element within the list. So X square brackets 2, I'll take the value at index 2, right? And then X 0 colon 2 means it'll give you the values starting from index 0 and stopping before index 2. So the second index is always exclusive, right? So it'll go from 0 and 1, but it won't include 2. So it'll be 1 and hello. Here are some basic list functions in Python. We have append, which is adding an item to the end of the list, inserting, which is adding an item at a specific index within the list, removing removes the first item from the list with that specific value. So let's say you have multiple values of the same in a list, they'll only remove the first occurrence of that value within the list. So we can also change the value at a specific index by doing X and then square brackets, whatever specific index we want to change, and then setting that value equal to a specific value that we want. So taking this example, we set X is equal to 1, 2, and 3. So what lists are in Python is what we call an object. So an object is like, so let's say like every computer is made up of like a certain amount of memory, right? So let's say like this is our memory for our Python program. Within that memory, when we do X is equal to 1, 2, and 3, we've created a certain block within our memory that stores these values 1, 2, and 3, right? So this is what we call an object. And then X is the reference to this object. So basically X is a hexadecimal number that stores the location of this object in memory. So X is what we call a reference or like a pointer. So like it contains the address of this list, right? So when we do Y is equal to X, Y is not, we're not creating another list, 1, 2, and 3, having Y be pointed to this. Instead, what it does is that Y is pointed to the same list as X. And this is important because let's say we change a value in the X list, right? Let's say X1, we change the first index to be 15. So now X contains the values 1, 15, and 3, right? But when we print Y, we also see that it's 1, 15, and 3 because they're both referring to the same list and not two copies of that list. And then we also have the append method, which just adds it to the end. And then we can see Y also reflects that change as well. So let's go back to the string. So a string is basically a list of characters, right? So we have, let's say, my name, Kyle, is basically a list of characters that are combined together to form a string, right? So we can access a certain element within that list. So the third index, which is 3. And then we can also see using the colon notation, we can take a specific chunk of that string. So starting from index 1 all the way till index 4 exclusive. So 1, 2, and 3, right? And then we can also have just a one value within this notation as well. So go from 2 all the way till the end of the string. If you don't specify a starting point. Same with not specifying a initial point here. We'll start from the first index all the way till the 0th index, which is the first value, all the way till index 4, but not including index 4. And then we can also have negatives, which will basically, so since this is index 0, this is index -1 and index -2 in Python, it will just loop to the end of the string. We also have basic methods for string. So we have length of string, returns the length of the string or number of characters. So basically the length of the list that contains that string. And then we can also change a certain object into a string. So let's say we have the decimal number 10.3, right? This data type right now is still a float or a decimal number, right? But we can use this str function to convert it into a string as well. So another important data structure in Python is sets. So what a set is it's similar to a list, but it's not ordered and it only contains one item that is like, so like, let's say we have B in set A, right? You will not have another B in set A. So no duplicates basically. So we can search for a specific element within a set using this notation. And then, so we also have some operations between sets. So let's do, for example, set A minus set B. What it will do is it'll take set A, which is A, B, C, D, and then it'll print out all of the elements that are not within set B as well. So C and D are within set B, right? So it will only print out A and B. This single bar line just will combine these two lists, removing any of the duplicates. So it will be A, B, C, D, E, F, and it'll remove these duplicates. This and symbol will combine the two lists in their commonalities. So the only thing common about set A and set B is C and D. So this and symbol will only print out C and D. And then this caret symbol will take the differences of set A and set B. So since C and D are both within set A and set B, it'll only print out A, B, and then E and F. Okay, so now let's move on to dictionaries, which is our final data structure we're going to talk about in Python. So dictionaries is composed of, it's also somewhat similar to a list, but a little bit different too, because we have key value pairs, basically meaning we have a key, which is on the left side of the colon, and then a value on the right side. So instead of just having each value correspond to an index similar to a list, we can specify a specific key for that value. So like this can be this doesn't have to be a string. It could be a integer as well, a float as well. So like a lot of the data types we've seen can be a key. And then to find whatever value as at a specific key, it's very similar to the list notation that we saw. We just do the variable of the dictionary with these square brackets and then the key value within, and it'll print out the value that's correspondent to that key. You can also add and remove to a dictionary, so that's why they're mutable as well. So let's say we wanted to change a certain value within our dictionary. So it's similar to a list, they'll set by using the square bracket notations, and within the square brackets, you put the key, and then you set that equal to whatever value you want. So now you can see 42 is changed to 99, and they're corresponding to the key of 2. And then you can also add a new key value pair within your dictionary by just setting a new key to a new value within the dictionary. It is important to note whenever you're adding a new value, you have to make sure that key does not exist within that dictionary, because a dictionary can only they have to have unique keys. So each one of these keys has to be different from each other. So you can't have, so this 2 cannot be a 7 instead here, or else you will just be changing this original entry of 7 here. However, however, you can have like one key being set to a value of two different values. We'll see that later on. So we can do like a delete method too. So removing basically from a dictionary, we can just completely remove the key value pair from a dictionary by using the square brackets of whatever the key is. And you can see it'll remove the key value pair of 2 and the value there from the dictionary here. So how do we go through a dictionary? So we use a for loop as we saw before. So address.keys, this function basically returns each one of these keys within your dictionary. And then we're doing, so for K, so K will take on the value of each one of these keys, right? So, and then we'll print K, which is each of these keys as we saw here. And then we print their correspondent values, which we use the square bracket notations with the dictionary name. And then you can also use the sorted function. Basically, it sorts the keys by alphabetical order in the case of strings. So John will come before Mary, which will come before Wayne. If your keys were, let's say, integer values, it'll sort them in ascending order. So 1, 2, 3, 4, 5, 6, etc. Okay, so list and dictionaries both have a way to copy the list and the dictionary. So let's say like we have a list that's L1 and then we do L2 is equal to list of L1. So back to our example here of like memory. So let's say we have L1 which contains 1, right? So L1 is a reference to L1. So L1 is a reference to this list, right? So instead of what we did here before, just setting Y equal to, or list 2 to be L1, we're copying the list. So we're creating another list within our memory of our computer, and we're having list 2 be pointing to this instead of list 2 being just pointed to the original list. So if you can see here, when we change the value in list 1 to be 22, and we print out list 1, it changes it to 22, but when we print out list 2, it's still 1 because we made a whole new copy of the original list. Similar idea with dictionaries. Instead, you're just using d.copy instead of the list with the parentheses. So functions in Python are important because let's say we have an action that we want to do multiple times, or some kind of like function that we want to like be able to like use repeatedly, but we don't want to rewrite it each time. So we can use this notation def, and then we have the name of the function here. And then in parentheses are what we call arguments or parameters for a function, in which when you're using the function, you can pass in these parameters. If you can see here, max 3, 5, you're passing in 3 as x and then 5 as y. And then here you have whatever your function is supposed to do. So if x is less than y here, we are returning x, and otherwise we're returning x, and otherwise we're returning y. So it's when we're running the function, we call the name of the function, and then we're passing in whatever parameters that the function needs. So 3, 5 example here. So 3. Yeah. So this should be 3 instead, but no big deal. So we're not gonna go over this idea of functions being objects because it makes functions a bit more confusing. We're gonna instead just talk about how to use functions a bit better. So functions, we can also set like default values within our arguments. Let's say x is equal to 3. So if we're calling this function foo without passing in any parameters, it will just use this default value, which is 3, and it'll print out 3. However, you can also give foo a parameter and it will override this default parameter. So instead, if we pass in 10, it will print out 10 instead of 3. And then we can also pass in different data types. So notice how our default data type for x was an integer, right? But instead we can also pass in strings, doubles, or like decimal numbers, etc. So here we can see that our parameters are that we define for foo is in ABC order, right? So instead here, if we explicitly say that C is 10 and A is 2 and B is 14, we don't have to place these in a specific order that we saw here, right? So instead we can do C first and then A and then B, and it won't matter. It will still print out 2, 14, 10 according to ABC. However, if you have, let's say like we didn't like specify what A was exactly here, right? So we needed to put that within the correct position of the function, and then C we can like put before B because we're explicitly saying that C is equal to 2 and B is equal to 19. Okay, so now we're gonna get into the object-oriented programming part of Python. And let's start off with saying what a class is. So a class is basically, so objects, let's make like a real world example of an object. So like an object can be, let's say like, for example, an employee at a company, right? Or it can be like an animal, like a dog. So what a class is it is a blueprint for an object. So let's say like we have an object that's a dog, right? So if in a class, we might say that like a dog has like an age and like a gender, or like a type of dog. And then there's also like things that dogs can do that are within the class as well, right? So dogs can like bark, for example, or eat food, for example. So these are all functions that we'll have within our class for a dog, right? So here's the syntax for a class. It's just class and then your name of the class. And then see, for example, in this, if you're like a UC student, you have like an age property and then like a full name, for example. So fields is basically, fields within a class is just the variables of the class. So like within this class, the variables x equals 0, y equals 0. So those are the fields. So like the attributes of a class, right? So let's say, go back to our dog example. Our fields for our dog would be like what we said was like age and like type of dog, gender of the dog, for example. Those would be our fields for that specific class. And then to create a specific instance of the class. So okay, so let's say like here I can show you. So we have, so instances of classes is basically like, let's say like we have a dog class, right? Let's say this is our code. This is our code, class of dog, right? Let's say our dog only has, let's say we're only like doing an age and then maybe like type, age and type. So what we're doing with this line is we're creating a specific instance of this class. So so within our memory block, we have a dog object here, and it has a specific age. Let's say we set it to be 12 and then type to be golden retriever. Okay. So I'll show you how to set these specific values later on, but what P1 is a reference to this object, right? So this is what we call a specific instance of this class. However, we can create another instance of this class of another dog to be 13, and then it to be like a poodle or something. And then let's say that this is P2. So as you can see, we've created multiple dogs using the same blueprint because they share like commonalities, even though they're different types of dogs with different ages, for example. And how we can access these variables within a certain object or a class is the reference variable dot your variable name. So p1.x is equal to 2. You're setting p1.x to be 2, and then p1.y to be -5 here. Okay, so how do we define methods in classes? So we have your def keyword from before, your name of the method, and then this self keyword, which is pretty important in Python. So self just refers to like the specific instance of the class. So self in this case could be this instance, and then it can also be this instance too. So it's like self is that like is its own specific instance of the class. So just note that you'll need to have first self to be the first parameter of every method you write in Python within a specific class. So here you can see within our class points, we have the function move. So we're moving a point. We have the self keyword, and then dx dy, which is just like increments of x and y, and we're changing x to be adding on to dx, and then y to be adding on to dy. So notice here how we accessed x to be p1.x, right, is equal to 7. Here we're doing self.x. So basically self in this case is p1. So that specific instance or that specific like block of memory of that object is self. So how we can call methods in Python of specific classes is we can have this is creating a specific object P. So point a new object at 3, -4. We can do p.move, or we can do the class name, which is point.move, and then we can pass in the object P here as, which is the same thing as the self, right? So constructors is pretty important in object-oriented programming. So this is the syntax for it in Python. We have def and then init, which is initialize, and then we have self, always have self, and then x and y. So what this is doing is whenever you're doing, let's say p equals 0.3 -4, right? So when you're creating an object, it'll always run the constructor for that object. So see, we have 3 is x here, and then -4 is y, right? So we're setting x to be 3 and then y to be -4 when we're creating that specific instance of the class. And then we also have the string method. So this is similar to Java's toString, which is basically saying, so let's say we have P1 is equal to, we have P1 is equal to, P is equal to 0.3 - 4, right? If we just try to print out P and we don't have a toString method, so this method written within our class, it'll print out the hexadecimal reference to the object. So like P1 is actually just like a hexadecimal number. Let's say like 0000001 or like some hexadecimal number, which is pointing to, so this is the location of our instance of the object, right? Oh, just print out this. However, we can write this method within our class. So it will print out, let's say like, we can specify to print out the age plus the type of dog that we have, right? Instead of printing out the location of our object, which isn't very useful. We're printing out, we can make it so it actually prints out the actual attributes of the object. So we also have inheritance in Java, in Python. So we have class name. So the syntax is the class keyword plus the name of the class, and then whatever superclass you have. So here, let's do a quick example. I'll write a quick example. Let's say we have a class that's like class employee. We have like a certain amount that we want. It's like a raise amount that they can have. And then like, we also have to have our constructor, right? So let's say we wanted to have their first name, last name, and like the amount that they get paid, right? So then we set these to the specific variables within the class. So self.first is saying that within this class, we have a variable called first, and we're setting it to whatever we're passing in here as an argument when we're creating the object. And then we have self.last equals last, self.pay equals pay, let's say we can create like a, so we can print their full name. So we return their first name plus their last name. This is concatenation between two strings with a space, right? And then we can do another function, which is like apply their raise to their pay, which is do their pay value and then pay multiplied by their amount that they should get raised, right? So this is a simple class. We're imitating an employee, an real life employee. So like inheritance basically means like, let's say you have an animal, right? A dog is an animal, right? But it's more specific than an animal. So like, let's say we have another class here that we have developer, right? A developer is an employee, right? So we can inherit all of the traits from employee. So I'm not gonna write anything within a developer right now. And then I'm gonna print so you can see here in our developer class, since we inherited from an employee, so we inherited their methods. So we got the methods that we had in employee, and we also got their instance variables or like their fields within employee, right? So this raise amount. So all of this is within developer, right? So we can also change or like override employees raise amount. Let's say for a developer, their raise amount is 1.1. Okay, so we can also have, so we also want to write a constructor for an employee, since it's could be more specific than a developer. We want to write a constructor for a developer because it can be more specific than an employee, right? Let's say a developer has a specific programming language that they know. So we have first, last, pay, and then like their programming language, right? So instead of copying this and putting it here like this, what we can do is we can invoke or we can call this constructor in the super class by doing super and then dot init and then first last pay. So it's much easier and we don't have to worry about typing out, like if we have multiple lines of like tons of different variables. And then we can also set the programming language to be equal to whatever we pass it, right? So some simple, so like, let's say we do employee one is equal to employee. And then we set their name to be Kyle. And then let's say their pay amount is like 50,000. Okay. And then let's say we do employee one dot raise, apply raise. So we're calling this method, right? And then let's say we print out employee one dot pay. Oh, self-raise amount. So you can see here, our raise amount is actually, so 0.04 times 50,000 is 2,000, right? So since we created an employee object, we can see that this raise amount doesn't actually change anything. So our subclass or our child class doesn't actually change anything within the super class, right? So our raise amount for employee is still 1.04. So when we created an employee object and did apply raise, it only did the rate for the employee, right? But like now, let's say like we change this to a developer. And then so they have a specific programming language, right? So Python, for example. And then now we did apply raise. So now the apply raise, the raise amount is 1.1. We can see here it's 50,500, 55,000. However, you can see within our developer class, we never actually defined this apply raise function, right? But since we used inheritance, we got both of these functions, plus we can override this specific variable, but we inherited both of these functions. So basically it's the same thing as us having these defined with ourselves within our class, right? So that is a specific or like the very basic application of inheritance and like why it's so useful. Because let's say we have a more complicated scenario with like tons of different classes that are all similar in a way, but we don't want to rewrite tons of different code. We can create a parent class and then inherit from that parent class to get all the similar methods between similar classes. So let's say like a dog and a cat both can like run, or they can both they both have like names and both have ages. We can write that within a parent class and inherit from that parent class, so we don't have to rewrite code multiple different times, right? So since it's 3:04, I'm pretty much at the end of the presentation. If you guys have any questions, you guys can drop it in the chat. I can answer them as best I can.